Hi friends, see in part 1 heat transfer we discussed up to I think growth of ice on a lake or pond. So that derivation is very important regarding IPE 4 marks question, that is dy by dt is equal to k into theta by rho L. Okay, you got some equation. Okay, very important derivation it is, very important, k theta by rho Ly. Okay, so up to there we have discussed in part 1. So that is finished now. We have derived also, and also we applied integration. In part 2 heat transfer part 2, we will be discussing about radiation effects. Radiation, as I told you, radiation, that means the direct attack of the light rays, that is electromagnetic waves, sun rays are nothing but radiation. There is no requirement of any medium. Directly it can travel without any medium like sound wave. For example, sound waves required medium, otherwise it cannot travel through vacuum. Clear? Now in radiations, let us see the first one, very important, Prevost theory. Okay, Prevost theory. What is Prevost theory? A scientist named Prevost has given theory for heat exchange. So therefore it is called as Prevost theory of heat exchange. So in this we will be dealing about the Prevost given some theories. That means what he said is every body will radiate and absorb energy at all temperatures. The first one he has given in Prevost is every body will emit and absorb heat energy at all temperatures. At all temperatures. He has given some concept, that is regarding heat energy. That means every body will emit and absorb the heat energy. For example, one body is at higher temperature, another body is at lower temperatures. Heat will transfer from high to low. It doesn't mean that lower temperature doesn't give heat. Lower temperature also give heat to higher. But because of it is at higher temperature, it will be in dominating position. So what does it mean? Every body will radiate, that means emit and absorb heat energy at all temperatures. At all temperatures. Okay, and he has given some more points also, that is when the absorption and emission takes place. Okay, when the absorption and emission takes place. For example, surrounding temperature is more. For example, surrounding temperature is more and body temperature is less. Body temperature is less. So if surrounding temperature is more, what happens? That body will emit energy. Surrounding body emit energy and this body will absorb. The body which is at lower temperature will absorb and the body will at higher temperature will emit. And one more thing, what happens when two bodies are coming together, because this will be dealing again in thermodynamics next chapter, that is last chapter, that is also thermal equilibrium. That means when any two bodies are brought together, temperature transfers from higher to lower. Even though lower is also giving temperature, because of the domination we feel that from the temperature is flowing from high to low, not from low to high, because according to Prevost theory, what is saying? Every body will radiate energy at all temperatures. It radiates and emits. Depending upon the temperature only, we will be saying it is absorption or emission. If surrounding temperature is more, it will emit temperature. If the object temperature is less, it absorbs the temperatures. Okay? So these are very important theory of Prevost. In the examination, you may be asking for 2 marks in IPE. Okay? That is, write Prevost theory. Every body will emit and absorb energy at all temperatures. Any temperature. If one body is at higher temperature, it will emit. If another body at lower temperature, it will absorb. The body is having lower temperature will absorb. The body will having high, it will emit. But every body will emit temperatures at all temperatures. Emit and absorb, both things takes place. That is Prevost theory. Okay. Now let us go to the next thing, that is emissive power. We'll see what is meant by emissive power. Emissive power and enti chuddam. So the term itself is telling emissive power. That means emission. Emissive power. Emissive power. So this I will write as E lambda. Why I am writing E lambda? At a particular wavelength. Okay. So emissive power ela define cheyachu? Emissive power means the amount of heat energy emitted per unit area in unit time. Okay. That means, for example, if you take a body, it is emitting energy, heat energy. It is emitting energy, heat energy, delta E or E. So how it will be emitting? The amount of heat energy emitted per unit area and unit time. So it is having some units. That is called emissive power. What is power? I told you, rate of doing work. So therefore here you can see this is work by time. Nothing but what? Work unit and MK unit, joule by area, meter square, time, second. So joule per second is equal to what? Watt. Watt per meter square is equal to SI unit of emissive power. The amount of heat energy at a particular wavelength, of course, it may be. That is why lambda I am writing. The amount of heat energy emitted per unit area in unit time of that body is called as emissive power. The SI units are, you can see, heat energy emitted per unit time, unit area units into meter square, time seconds, joule per second is again rate of doing a power. So watt per meter square leda watt meter power minus 2. Either you can write watt per meter square or watt meter per minus 2 is the SI unit of the emissive power of any body. So emissive power of any body can be defined as the amount of heat energy emitted per unit area in unit time. Okay. So units also are given here, watt per meter square or watt meter power minus 2. Clear? And lambda is at a particular wavelength. Let us go to the absorptive. All are easy definitions. So these are coming for 2 marks in IPE. 2 marks derivations, definitions, not derivation. Now let us go to the next item, that is absorptive power. Second one, that is absorptive power. Absorptive power of a body. Now this one I will write as A lambda. Okay. There are some letters given by the orthodox, the scientists, given by the scientists. A lambda, that means at a particular wavelength. Now how can you define absorptive power? For example, this is a body. Now on this body, suppose the light is incident, heat energy. Now any body is getting some heat energy means it cannot absorb the entire heat energy. Only a fraction part is absorbed. For example, 100 is felt. Say, for example, 100 is incident on the body. Suppose this body is absorbing, say, 30. Say, for example. ఎందుకంటే బాడీ మొత్తం అబ్జార్ప్షన్ చేసుకోదు ఏ బాడీ కూడా. ఓకే, ఎక్సెప్ట్ బ్లాక్ బాడీ. బ్లాక్ బాడీ అయితే పర్ఫెక్ట్లీ బ్లాక్ బాడీ అయితే మొత్తం అబ్జర్వ్ చేసుకుంటుంది, మొత్తం వదిలేస్తుంది, మళ్ళీ ఇట్ రిలీవ్స్. సో ఫర్ ఎగ్జాంపుల్ దిస్ ఈజ్ ఎ బాడీ. Let the incident light be, heat energy be 100. Let the absorption be 30. Now how will you define absorptive power? Absorptive power of a body can be defined by heat energy absorbed by heat energy incident. So how can you define absorptive power of a body? A lambda can be defined as the amount of heat energy absorbed, okay, to that of incident. For example, in this case, how much absorbed? 30. By how much it is incident? 100. That means how much? 0.3. So what is A lambda absorptive power? 3 by 10 or 0.3. Therefore, because it is ratio of heat energy absorbed by heat energy incident, it is a dimensionless and it doesn't have any units also. Because it is the ratio of heat energy absorbed to that of incident. ఒక fraction value అది, అందువల్ల it doesn't have any units and dimensions. For example, I given some value. If 100 is incident, 30 is absorbed, 30 bended. Amount of heat energy absorbed to that of incident. That is the absorptive power. Okay. Now let us go to the what is meant by ideal black body and also black body. See, ఇందాక చెప్పాను మీకు వాట్ ఈస్ ఎ పర్ఫెక్ట్లీ బ్లాక్ బాడీ. బ్లాక్ బాడీ అంటే ఏంటి అసలు యాక్చువల్గా? హౌ కెన్ యూ డిఫైన్? ఓకే, see in general what is a black body, we'll try to define in general. Black body, దీన్నే తెలుగులో కృష్ణ వస్తువు అని అంటారు. So what is a black body means? Black bodies are those which will absorb the entire heat energy falling on it and emit out all the heat energy felt on it. అంటే ఒక బ్లాక్ బాడీ ఏదైనా తీసుకున్నట్టుగైతే కృష్ణ వస్తువు, దిస్ ఈజ్ ఎ బ్లాక్ బాడీ. సో whatever light energy, heat energy is falling on it, it will absorb entirely. That is a perfectly black body. It will entire heat energy absorbs and again relieves, emits out all the heat energy. That type of body is called as a perfectly black body. So for an ideal black body, ideal అంటే తెలుసు కదా, imaginary. Ideal అనేది ఉండదు అక్కడ, it is an imaginary. Ideal బ్లాక్, ఎప్పుడైనా ఐడియల్ అనే మాట వాడితే ఇట్స్ ఐడియల్ అంటే ఇమాజినరీ. నిజమైన ఐడియల్ అనేది ఉండదు. ఓన్లీ ఫర్ ఎక్స్ప్లెనేషన్ ఫర్ పర్పస్ వీఆర్ టేకింగ్ ఐడియల్. ఐడియల్ ఈజ్ ఆల్వేస్ ఇమాజినరీ. ఓకే, సో ఐడియల్ బ్లాక్ బాడీ ఒకవేళ తీసుకుంటే వాట్ ఈజ్ ఏ లాంబ్డా? సి ఫర్ ఐడియల్ బ్లాక్ బాడీ అబ్సార్ప్టివ్ పవర్ ఈస్ ఈక్వల్ టు 1. దట్ మీన్స్ ఇమాజినరీ బ్లాక్ బాడీ. ఓకే, ఫర్ దట్ for any wavelength, any wavelength, okay, any wavelength, the absorptive power for ideal black body, the absorptive power is taken as 1. And not only that, reflection is 0. Not only that, reflection is 0. No reflection. అంటే అర్థం ఏంటి? మొత్తం అంతా అబ్జార్బ్ చేసుకుంటుంది. వాట్ ఎవర్ ఎనర్జీ is felt on that body, all it absorbs. Reflection 0 అంటే అర్థం, nothing is reflected, all is absorbed. ఎవరికిది? For an ideal black body, because the absorptive power you have taken is 1 here, reflection is 0. Okay, and also you can take 0 transmittance. Okay, 0 transmittance, 0 transmittance. Okay, మొత్తం అబ్జార్బ్ చేసుకుంటారు. 0 reflection, no reflection will be there, and 0 transmittance. Okay, and the value for absorptive power for perfect ID, that is ideal black bodies, ఎంతది? 1. ఐడియల్ ఎందుకు వాడానంటే ఓన్లీ ఫర్ ఎక్స్ప్లెయిన్. ఐడియల్ అనేది ఉండదు ఎనీవేర్. ఐడియల్ బ్యాటరీ, ఐడియల్ ఫ్లూయిడ్, ఇట్ ఇస్ ఓన్లీ ఇమాజినరీ. ఫర్ ఎక్స్ప్లెయిన్ పర్పస్ విల్ బి టేకింగ్. సో ఇక్కడ 0 రిఫ్లెక్షన్, 0 ట్రాన్స్మిటెన్స్. ఓకే, నౌ let us go for lamp black body. Let us see what is a lamp black body. Next one, what is a lamp black? For example, see here, we'll do one thing. Before going to the lamp black body, let me tell you one more point is left over. Okay, we'll do later on then. Let us explain first of all what is lamp black. Okay, what is lamp black? For example, చూడండి ఒకసారి ఇది. Suppose this is a object made in this fashion. A small groove-like structure. Okay, and this is a small entrance to enter the light from outside. Light from outside, it may be sunlight. Okay, so light is entered like this in this fashion. Not only is a small angle, 45 degrees angle, a small piece is kept. Why like that? See, whatever light is coming, hitting, it will reflect and take number of reflections. It will take more number of reflections. Okay, so because why it is kept at an angle 45 degrees, a small metal, because when the light is entering, it has to make a number of reflections. ఎందుకు చేయాలి reflections? Not only that, the inside part is completely coated with black. Okay, the inside part of that material is completely coated with black, lamp black. Okay, it is special material. Why lamp black is coated inside? So that whatever heat energy is entered into that groove, total energy to absorb, to reduce రిఫ్లెక్షన్స్. అంటే ఈ కంటిన్యూస్ రిఫ్లెక్షన్స్ అవ్వడం వల్ల ఏమవుతుంది, ఎనర్జీ బయటికి ఎస్కేప్ అవుతుంది, మొత్తం అబ్జార్ప్షన్ అవుతుంది అనమాట. క్లియర్? సో వాట్ ఎవర్ ఈ లైట్ ఎనర్జీ ఇస్ కమింగ్ ఇన్సైడ్ డ్యూ టు రిఫ్లెక్షన్స్, ద ఎనర్జీ మ్యాక్సిమం హీట్ ఎనర్జీ ఇస్ అబ్జార్బ్డ్. క్లియర్? రైట్. సో ఓకే, so this is about this lamp black story. Okay, so when heat is coming from outside, after hitting this groove to the 45-degree angle metal plate, maximum reflections have taken place and total మొత్తం ఎనర్జీ అంతా అబ్జార్బ్ చేసుకుంటుంది. అంతేకాదు ఈ లోపలికి వచ్చిన తర్వాత ఇట్ హ్యాస్ టు బిహేవ్ ఇట్స్ ఓన్ like a black body. అంటే లోపలికి వచ్చిన తర్వాత the heat energy is absorbed completely because of reflections. Nothing is wasted outside. That is why this metal is kept at an angle 45 degrees. And not only that point, one more is there. ఏంటంటే బయట ఏవైతే ప్రాపర్టీస్ ఉన్నాయో initially when it is not entered, those properties it has to lose after entering inside the groove. After entering inside, whatever properties it is having initially, it has to lose all those properties and it has to behave like the black body only, because now after getting reflections, what happened, inside a black coating is given, lamp black, లోపలంతా lamp black coating ఇచ్చారు. ఇవ్వడం వల్ల ఏమైంది, మొత్తం ఎనర్జీ అంతా అబ్జర్వ్. వాట్ ఇస్ ద బ్లాక్ బాడీ ప్రిన్సిపల్? ఇట్ అబ్జర్బ్స్ ఆల్ ద హీట్ ఎనర్జీ ఫాలింగ్ ఆన్ అండ్ ఎమిట్స్ అవుట్. సో maximum energy is absorbed and now this light will behave as a black body. Whatever black body principles are there, same properties it will obey. Outside properties will not be there, because now it has entered inside, absorbed, and it behaves like a completely black body. Okay, sometimes they may ask these questions also regarding this groove. Okay, in IP examinations, that is regarding lamp black explanation. Okay, now I think we are coming to the next one, Kirchhoff's law of heat radiation. Next part is Kirchhoff's law of heat radiation, not Kirchhoff's law of electricity. This is Kirchhoff's law in heat radiation. Kirchhoff's law in heat radiation. So according to the scientist, what he has given is the emissive power what he is saying is the ratio of emissive power to that of absorptive power is equal to the emissive power of a perfectly black body. Okay, so examination when IP lo 2 marks question adavachu, what is Kirchhoff's law of heat radiation? The emissive power ratio of emissive power to that of absorptive power of a body is equal to the emissive power of a perfectly black body. Okay, is equal to the emissive power of a perfectly black body at same temperature and same wavelength. Okay, the ratio of emissive power to that of absorptive power of a body at a particular wavelength, of course you can take at a particular wavelength at a particular temperature is equal to the emissive power of a perfectly black body of same wavelength and same temperature. So this is Kirchhoff. Even definitions and theoretical questions కొంచెం బోరింగ్లా అనిపించవచ్చు, బట్ యూ హ్యావ్ టు, బికాజ్ ఇన్ ద ఎగ్జామినేషన్ దే ఆర్ గివింగ్. నెక్స్ట్ వన్ Wien's displacement law, okay, or Wien's displacement graph. Next one is Wien's, scientist given, Wien's displacement law. సో ఈ వైన్ అనే సైంటిస్ట్ మనకు ఒక గ్రాఫ్ ఇచ్చాడండి, lambda versus intensity of light. Let us see the graph. On x-axis lambda wavelength and intensity of light Q by A into T. On y-axis, okay, amount of heat energy emitted per unit area and unit time. So intensity is taken on y-axis. Now the graph goes like this initially. This is the maximum wavelength. Okay, and the intensity values are also, you can see, gradually increasing. Okay, you can take some values 2, 4, okay, 5, 10, 2, 4, 5, 10, so on and so forth. These are the intensity values, intensity of heat values, because the amount of heat energy emitted per unitary and unit time, intensity of light, heat energy, and the wavelength on the x-axis. So this is the maximum wavelength, you can see. This is maximum intensity, this value, and this is maximum wavelength. Okay. So according to Wien's displacement law, what is trying to tell? Let us see that one. ఏం చెప్దాం అనుకుంటున్నాడు వైన్స్ సైంటిస్ట్? That means if lambda wavelength is taken on x-axis and if the intensity is taken on y-axis, the graph goes like this. See, for example, this is first one for T1 temperature, this is for T2, and this is for T3, so on and so forth. You can see the graph here, the lambda, here lambda maximum 1. Now the lambda is shifting to here, lambda maximum 2. Again you can see lambda maximum 3. You can see this one, lambda maximum 4. See what is happening here? As you go, as you raise the temperature T1, T2, T3, T4, when you increase the temperature, what happens? The wavelength is decreasing. Wavelength is decreasing. That means what happens here? Wavelength inversely proportional to temperature. Wavelength is inversely proportional to temperature. అంటే wavelength పెరిగితే టెంపరేచర్ తగ్గుతుంది, టెంపరేచర్ పెరిగితే wavelength తగ్గుతుంది. You can see here wavelength is increasing or decreasing here. You can see the intensity is increasing. These are the intensity values. Okay, so you can see first the graph for T1 temperature, the graph, the maximum is here. First ఇక్కడ వచ్చింది. For T2 temperature, lambda decrease. అంటే అర్థం ఏంటి ఇక్కడ? T1 increase అయితే temperature, if the temperature is increasing, wavelength is decreasing. You can see T1 here, temperature increase అవుతుంది, wavelength తగ్గుతుంది, inversely proportional. For T2, T3, so gradually what is happening? Wavelength, maximum wavelength is inversely proportional to the temperature or absolute temperature. This is called as Wien's displacement law. As you see the temperature, okay, T1 you got lambda, T2 lambda తగ్గిపోయింది, T3 ఇంకా తగ్గిపోయింది lambda. Okay, so for a particular T1, T2, T3 compare చేసుకోండి. For T1 it is lambda maximum 1, for T2 lambda maximum 2, for T3 lambda maximum 3, so on and so forth. So which is more? Here you can see lambda maximum 1, you can see it is more than lambda maximum 2, then lambda maximum 3. So you can observe here very clearly, this value is more than this, this value is more than this, this value is more than this. So lambda 1 greater than lambda 2 greater than lambda 3, so on and so forth. So maximum wavelength is inversely proportional to the temperature absolute. This is called as Wien's displacement law. Okay, or you can also write in this fashion, lambda t is constant, lambda t is equal to constant. That constant is also, you can take it some b value, that constant also you can take it as some b value, and it is also having some value. The SI unit are in meters and Kelvin, around 2.89 in 10 power minus 3. 2.89 in 10 power minus 3 meters degree Kelvin, SI unit. What is the value of that constant? Lambda t is equal to b. That b value was found to be 2.89 into 10 power minus 3 meters degree Kelvin. This is the value of the constant. So this is about the Wien's displacement law. Clear? Now let us go to the next one. All are theoretical points here. What are coming now? All are theoretical points. After this Wien's displacement law, now let us go to the second last one. Second last term. Second last term, that is Stephen's law or Stephens-Boltzmann's law. Very, very important in bit questions. Next one is Stephen's law or Stephens-Boltzmann law. Stephen, scientist, Stephen and Boltzmann. Stephens-Boltzmann law, or simply you can call it as Stephen's law. Stephen's law. Okay. Now what is the Stephen's law of heat radiation? See, he has given very simple. The amount of heat energy emitted per unit area. Okay. Emitted per unit area. Amount of heat energy emitted per unit area in unit time directly proportional to fourth power of absolute temperature. Stephens-Boltzmann law ఏం చెప్పారు సైంటిస్ట్ స్టీఫెన్ లేదా స్టీఫెన్స్ లా ఏంటంటే ఎనర్జీ ఎమిటెడ్ హీట్ ఎనర్జీ ఎమిటెడ్ పర్ యూనిట్ ఏరియా యూనిట్ టైం డైరెక్ట్లీ ప్రపోర్షనల్ టు ఫోర్త్ పవర్ ఆఫ్ అబ్సల్యూట్ టెంపరేచర్. ఓకే, ఫోర్త్ పవర్. లేదా యూ కెన్ రైట్ దిస్ ఈక్వేషన్ యాజ్ E proportional to A T power 4, or removing the proportion, introduce a constant sigma T power 4. Okay, this A is area, T is time, T absolute temperature, Kelvin temperature, and putting these values, he has given the value also 5.67 into, that is Stephen's constant sigma. Okay, sigma is also called as Stephen. So 5.67 into 10 power minus 8. What will be the units? You can see E by AT T power 4. E energy, unit joules, area meter square, time seconds, temperature kelvins. So joule per second ఏమవుతుంది watts. Joule per second into watt. Watt per meter square Kelvin, లేదా watt meter per minus 2 Kelvin per minus 4. This is the SI unit of Stephen's constant. Okay, ఏంటి వాల్యూ watt per meter square Kelvin per 4. Okay na, please check it. Watt per meter square Kelvin per 4. ఏరియా కదా, ఏరియా యూనిట్ ఏంటి మీటర్ స్క్వేర్, ఫోర్త్ డిగ్రీ కదా, ఫోర్త్ పవర్ ఇక్కడ. సో Kelvin per minus 4. Clear? So these are the units and things you have to remember. Very, very important. And also here some more conclusion is also there, that is you can take the E value. You can also introduce E also here. Okay, I'll give that value E. That is, you can see, right. Have you copied this one? This is Stephen's constant sigma. Okay, sigma is called as Stephen's constant. It is got by putting all these values. E value, A, T power minus 5.67 into 10 power minus 4. Okay na? Energy emitted per unit area, unit time, directly proportional to fourth degree, fourth power of absolute temperature. Okay, energy emitted. So that is Stephen's law or Stephens-Boltzmann's law. Okay. Now we are entering into the last part of this topic, heat transfer, that is Newton's law of cooling. Very, very important in IPE 4 marks question, and also in entrance examination also they are asking. Okay, in entrance exam also regularly they are asking this one. That is Newton's law of cooling. ఏంటది? Newton's law of cooling. Very, very important question. ఏం చెప్తారు న్యూటను? ఫర్ ఎగ్జాంపుల్ యూ హ్యావ్ డిఫరెంట్ బాడీస్. Suppose this temperature is say 70. It has reduced to 60 in time T1. Now again the 60 degree centigrade, of course, degree centigrade, reduced to 50 degree centigrade in time T2, to 40 degree centigrade in time T3, so on and so forth. 30 degrees centigrade in T4. I am trying to explain Newton's law of cooling. Newton's law of cooling ఏం చెప్తున్నాడు? For example, a body's temperature is at 70 degrees centigrade. Now it has fallen to 60 in T1 time, again 50 T2 time, 40 T3 time, 30 T4 time, 30 in the T4 time. Now according to Newton, what is given is the rate of cooling. The rate of cooling, అంటే టెంపరేచర్ తగ్గిపోతుంది, యాక్చువల్ మైనస్ ఉండాలి అక్కడ, బికాస్ డిక్రీజింగ్. రేట్ ఆఫ్ కూలింగ్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు మీన్ ఎక్సెస్ టెంపరేచర్ ఓవర్ సరౌండింగ్స్. మీన్ ఎక్సెస్ టెంపరేచర్ అంటే ఏంటి? θ1 ప్లస్ θ2 బై 2 మైనస్ θ0. Here θ0 is surrounding temperature. θ0 is surrounding temperature. Okay? Let us take surrounding temperature 25 degrees centigrade. Let us assume. Let us take surrounding temperature as 25 degrees centigrade. And what is θ1 plus θ2 by 2? That means the average of the temperature falling. Okay? 17 is 60 పడిపోయింది కదా, the average. For example, here you can observe 70 to 60 అంటే 70 plus 60 by 2, 130 by 2, 65 degrees. Okay? This is the formula given by Newton. Okay? The rate of cooling అంటే ఫాస్ట్గా కూల్ అయిపోతుంది. ఎంత టెంపరేచర్ ఎక్కువ ఉంటే అంత ఫాస్ట్గా కూల్ అవుతుంది. మోర్ టెంపరేచర్, more fastly it will be cooling. Okay? So here you can, that is why the negative sign I am using. Why I am using negative sign? Because rate of cooling, temperature is falling, high to low. So but I will take magnitude, I will remove that negative, I will take magnitude. Therefore dt by dt. What is dt here? dt means temperature difference, please. What is dt? Temperature అంటే 17 is 60 పడింది అంటే ఏంటి? 70 minus 60. And what is small dt? Time. Time. What is small dt? Time. θ1 plus θ2, 70 plus 60 by 2. θ0, surrounding temperature. So this formula we will be adopting for the above numerical now. Now we will apply here. So this is the definition of Newton's law of cooling. Rate of cooling of any body is directly proportional to the mean excess temperature over surrounding. That is mean excess అంటే θ1 plus θ by 2 minus θ0. θ0 is the surrounding temperature. θ1 plus θ2 is the average temperature of the falling. 70 to 60, 60 to 50, 50 to 40, 40 to 30. Now I will apply this formula for this numerical and let us see. Let us see what happens. Now for the above problem I will apply the system here. What is the formula? dt by dt is equal to constant into θ1 plus θ2 by 2 minus θ0. I have taken magnitude, negative sign తీసాను. Rate of falling అంటే పడిపోతుంది కదా, that's why I will remove the negative sign. I am taking magnitude. Here k is constant. K is constant. Now I will apply for the first body here. Here to here falling. Okay? 17 is 60 పడిపోయింది అంటే అర్థం ఏంటి? What is dt here? 70 minus 60, how much? 10 degrees centigrade. So 10 by dt, what is the time? T1 is equal to k into θ1 plus θ2, 70 plus 60 by 2 minus surrounding temperature given, take some 25. So what happens? 10 by T1 is equal to k into 130 by 2. What is 130 by 2? 65. 65 minus 25 ఎంత అవుతుంది? 40. So 10 by T1 is equal to k into 40. 0 0 cancel. So finally ఏమొచ్చింది నాకు? How much I got? K is equal to, what is k? 1 by 4T1. So I got the constant value how much? 1 by 4T1. Leda, if you want T1, 1 by 4K. Okay? If you want constant value, you can calculate T1 value. T1 ఎంత వచ్చింది? 1 by 4K. See here? What is T1? 0, 0 cut అయిపోయింది కదా 1 by 4K. This is the first case. Now in the same way apply for second case. Same way apply for the second case. We'll see what happens. Second case చూద్దామా? Right. Second case apply చేద్దాం. Surrounding temperature ఎంత అన్నాను? theta 0. 25 degrees centigrade. I'll apply for second one. dt by dt అంటే ఎంత అవుతుంది? Same thing here also. 10 by T2 is equal to K into 60 plus 50. 60 plus 50 by 2 minus 25. So 10 by T2 is equal to K into 110 by 2. 110 by 2 and 55 kada? 55. So 55 minus 25. So 10 by T2 is equal to K into ఇది ఎంత అవుతుంది 30. 5 0 3 0 0 cancel. Now again what is T2 here? 1 by 3K equation 2. See here? What is T2 from here? 1 by 3K. Okay? In the same way solve for the last one and compare the values of time. Solve for the last one, compare the time. What will be the last one? Last one ఎంత అవుతుంది? 40 minus 30 again. 10 by T3 is equal to K into 40 plus 30. 70 by 2. 35 minus 25. Okay na? 70 by 2 కదా average theta 1 plus theta 2 by 2. 70 by 2 ఎంత? 35. Okay? So ఇప్పుడు ఎంత అవుతుంది? 10 by T3 is equal to K into 35 under 10. Okay? 20 by 10. 0 0 cancel. What is T3? T3 is equal to 1 by K. Now tell me, out of these three equations, which time is larger? You can see. Here denominator you are going to increase it. For T1, denominator is more. Here denominator is less. Here still less. So, ఈ మూడిట్లో T1, T2, T3 కంపేర్ చేస్తే దేని టైం ఎక్కువ ఉంది? Whose denominator is more, that value will be less mathematically. More denominator, less value. Less denominator, more value. ఇక్కడ చూడండి T3 is more. T3 is more according to the problem. Next T2. Next T1. ఓకేనా? లేదా ఇక్కడ T1 less than T2 less than T3. See, from this problem I am telling, not in general way. According to this problem I am telling you. Okay? According to this problem we got the values time. T1 time. Okay? So according to this problem what I got? T1 1 by 4K. 1 by 4K. Here 1 by 3K. Here 1 by K. So whose denominator is larger? 4K. Okay, K is a constant value. You can multiply some value. 4, 3, 1. So which is larger? Even if you take LCM also you can find out. In other words, 1 by 4, 1 by 3, 1 by 1. LCM is 12. 4 3s are, 3 4s are, 1 into 12. So this is larger. Okay na? Every denominator, according to mathematics, if denominator is more, value is less. If denominator is less, more value. So it is having more value. And T3 is greater than T2. T3 is greater than T2. T2 greater than T1. అన్నిటికన్నా తక్కువ ఎవరి టైము? T1. T1 is lesser than T2 lesser than T3. Clear? So this is how you will be explaining the Newton's law of cooling. So I think this is the end of the heat transfer chapter in part 2. So please study well for the examination. Okay? Again we will be meeting in the last chapter, that is thermodynamics.